Apple is doing something this September with its dark cherry chassis that it has never done before. For the first time in a decade, there will be no standard iPhone released at their fall event. This chart illustrates the break in their historical release cycle. Instead of the usual four-phone lineup, the standard iPhone 18 and 18e are pushed to spring 2027. That leaves only the Ultra Premium Pro and Pro Max isolated for the main September launch. Focusing exclusively on models priced at $1,000 and up means Apple is betting its Q4 revenue on a single tier of hardware. It suggests the technology inside the specific chassis was considered significant enough to anchor the premiere window without the support of an entry-level model. The Pro Max represents a shift where microscopic hardware advancements and heavy on-device intelligence converge into a single unit. It is a foundational change to the internal architecture of the device. At the core of the device is the new A20 Pro chip. Apple has secured the industry's first 2-nanometer fabrication process for this processor, meaning the transistors are packed tighter than any previous generation. This bar chart compares the previous 3-nanometer chips with the new 2-nanometer architecture. We see a 15% increase in processing speed, but the critical metric is the 30% spike in energy efficiency. That smaller node allows Apple to implement a major engineering breakthrough called wafer-level multi-chip module packaging, or WCM. This schematic shows standard architecture morphing into WCM. Normally, the processor and the memory sit apart, so data has to travel across a substrate to reach the core. Here, the processor and the memory are fused directly onto the exact same silicon wafer, drastically shortening the physical path for every bit of information. Because the memory is directly adjacent to the processing cores, the data loops instantly without leaving the chip. This allows the device to process complex generative AI tasks directly on the hardware, removing the need to wait for a response from a remote cloud server. The A20 Pro makes intelligence a permanent feature of the silicon, moving the heavy lifting of AI processing into the physical structure of the chip itself. That focus on physical hardware now extends to the 48-megapixel main camera, which features a variable aperture system. Almost every smartphone camera ever made has a fixed aperture, meaning the lens opening is always one size. In bright conditions, the phone has to use software to avoid overexposure. Professional DSLR lenses, however, adjust the lens opening mechanically. This cross-section shows how the new variable aperture physically adjusts to the environment. The lens mechanics literally open wide to pull in light during night shots and narrow to restrict light when you're shooting in bright sunlight. Because the mechanism controls exactly how light hits the sensor, you no longer need software-generated blur to create a portrait. You get true optical depth of field created directly by the glass and the physical blades of the aperture. The addition of variable optics moves the Pro Max out of the category of a digital image processor and turns it into a functional mechanical camera. Moving to the front of the device, Apple is relocating the Face ID flood illuminator and housing those sensors beneath the screen glass. This comparative overlay shows the direct result of that sensor shift. The bounding box cuts the footprint of the dynamic island by 35%, returning a noticeable amount of screen real estate back to the user interface. Behind that display is a physical battery capacity of roughly 5,200 mAh. When you pair that massive cell with the 30% energy efficiency gain from the new 2-nanometer chip, the device approaches a realistic 2 days of runtime on a single charge. To manage the intense heat generated by heavier computing workloads, the chassis integrates a new vapor chamber cooling system. It works in tandem with the A20 chip to dissipate heat, allowing the phone to run sustained AAA console-level games without dropping frames or throttling performance. These architectural changes bypass the standard mobile trade-offs, where high-performance tasks lead to immediate battery drain and thermal overheating. The final major upgrade hidden in the chassis is Apple's new C2 baseband modem, which integrates with low Earth orbit satellite networks. This globe illustrates how the connection works. Previous satellite features were restricted to emergency text messages. The C2 modem bypasses disconnected terrestrial cell towers entirely, routing directly up to the satellite constellation to provide full web browsing and data access. While download speeds are restricted compared to standard 5G, the capability grants the user off-grid global connectivity regardless of whether a local cell tower exists. We are looking at three distinct pillars of engineering: integrated memory for local AI generation, physical camera optics reacting to light, and internet delivered directly from space. By merging local AI processing with mechanical optics and direct satellite data, Apple has assembled a device designed to operate independently of the traditional cellular and cloud-based infrastructures that defined the first 2 decades of the smartphone.